Well, thank you very much, Eric, for providing this overview. So in 2011, we invited or we asked for help from Ario Imaging to be able to capture imagery for protein estimation. And we did this test in 4 farms with Landsat 5TM sensors. And also partially in Santa Teresa, we use the UAV technology provided by Aria Imaging. It was a 1 meter resolution. I believe it was 1 meter resolution resampled to 5 meter resolution. So it was, I'm going to turn on some layers to see the resulting layers we got. So as you saw, we couldn't cover the whole field for technical difficulties, but still a technology under development. So we hope that as we move forward, this will become available at a large scale and also at an affordable cost. But just to give you an idea of how it looks like, this is NDVI capture at 1 meter resample to 5 meter resolution. So it's 5 meter. It's really pretty provides a good level of information, and it's also enough for the purpose that we're pursuing. Also, when we relate sample locations with imagery, the accuracy of the GPS samples may not be higher than that. So it really doesn't. That's why we take everything at that 5 meter level. So again, we acquired this imagery 45 days prior to harvest in the antithesis stage. And in addition, this year we were looking to, in addition to yield prediction, we're also intending to estimate the protein level to support the variable rate fertilization, and then also maybe differentiated harvest by quality based on the differences in protein. And so random and pre-located samples were taken. Pre-located means that they are marked in the field so they can be calibrated properly with the imagery that was taken. Collecting three variables, spikes per square meter, grains per spike, and SPAT measurement. This is a SPAT device that provided chlorophyll values. Again, this is the UAV that we used to obtain an index that was adapted to the predicted reference values similar to the SPAT chlorophyll meter. So there are indices that have been developed to determine chlorophyll content. One very well known, it's Sicario Sabe index. And this is a formula, if you remember our information about the different, the multispectral range and the different bands that we could use. And this is a range of reflectance that is used in this index. So what Eric was mentioning, that you could really get any index you want from the imagery because you have control of the bands you're going to acquire. So this is a formula for the index, and we were able to verify, which is logical, a strong correlation with the chlorophyll index and the SPAT measurements. So that way we were able to extrapolate a map with the SPAT measurements for the field. So, and I should ask a question, if you have ever measured chlorophyll or do some type of tissue testing, if you have used a SPAT meter to measure. This is, I'm going to turn on the SPAT meter. So this is what we had based on taking those samples and then extrapolating those values to the whole field based on the chlorophyll index. So this is like taking the chlorophyll measurements throughout the field. So this was step number 1. The next step was yield prediction, and what we did is we took the curves from last year and we adjusted previous year's curve relating spikes per square meter and grains per spike with NDVI values, we saw that a curve, not a linear, not just a straight line, had a better relationship between these variables, the spikes per square meter and the NDVI. So this was able to be adjusted based on last year and this year. And the same with grains per spike. And this is similar to what I saw in the Oklahoma State University curves, which is not a straight line. Also, they are getting some type of relationship curve between grain yield and NDVI. So the good thing is that these are relationships that are developed based on local values, and then they are adjusted year after year. So the next step was just like the year before. It was estimated a yield prediction, extrapolating those variables to the entire field and calculating the estimated yields. So these are the yield values we got anywhere between 4 and 6 tons per hectare. And also there's previous work that relates yields, chlorophyll, and protein level. So the protein level has a strong relationship with the yields and chlorophyll content. So that's based on that work. It's the protein level is a function of both variables, and it's the map of protein is derived. Here we see ranges from 9 to 13 or to 12-13% of protein level. Really, the threshold for quality is around 11. So it would be very beneficial first to know where the lower percentages and the higher, and then be able to correct this in late fertilization. There was one question that Eric was wondering today when we were talking before the presentation, which is if you're using any type of in-season fertilization. So if you'd like to share that, please go ahead. I'll leave it open for a few more seconds. And so, and again, we have 2/3 that are using this, and 1/3 that is considering for the future. So there's an important aspect about late fertilization in wheat, and each crop has their own characteristics. And also this was work based on Berg, a researcher from the INTA, a research institution, a little bit like the ARS in the US, maybe a combination of ARS and NRCS, because they do applied research and they also do some technical assistance. Not to the extent of the NRCS, but at least they provide recommendations, more like the ARS or University Extension Office. So based on this work, which is nitrogen fertilization for quality in bread wheat, they analyzed the effect of late fertilization on protein levels, and they found out, they did a couple of hypotheses with 20 and 40 kilograms per hectare of nitrogen, and they saw increments between 0.5 and 2% and between 0.8 and 2.7 for the 20 and 40 nitrogen rates, depending on the previous nutrient level of the crop. So that's the nutrient level on the leaf, and that's on the y-axis we have the increase in percentage. So based on that work, then a prescription map was developed to apply supplemental nitrogen in those areas. If you remember, we had lower areas of protein levels, and so in those areas it was recommended to apply 20 or more kilograms per nitrogen. Since this was the first year and the turnaround was not quick enough for a number of technical reasons, Molinos decided to apply 20 in the whole field, and they will be doing some georeference samples for protein prior to harvest to verify the validity of this approach.